Okay, so let's wrap up section 1.3/1.4 by putting it all together. All right, so as we've seen and we have relearned, there's basically four different methods to solve a quadratic algebraically. Factoring, right, and then taking use of the zero factor property, the square root property itself, the quadratic formula, or completing the square. All right, now these two over here get some high marks because they work all the time. So these are pretty good default methods. Matter of fact, I think a lot of you like the quadratic formula, but as I mentioned, make sure you know how to do completing the square, because that's where all the good math's at. Factoring, well, factoring is nice too, but it only works if we're factorable. If we're not factorable, we have problems. And then the square root property, right, we need something of the form x minus 8 squared equals a number. So something squared equals a number. So this needs something very specific to happen, right? Or we set it up by completing the square. Factoring, I need to be factorable, and then we have two methods that work all the time. So the reason I kind of went over that is because I'm asking us here, we're going to solve all four of these, and we're going to use all our techniques, but you can only do it once. So once we factor something, we can't factor something else. Once we use completing the square, we can't use it somewhere else. So this is going to kind of help us make some choices and get a feel for, one method actually is probably faster than another. All right, so that's what we're going to see us do here. So we're going to use all four methods, and we're going to decide which method works good and why. So let's begin. I think if you look at this very closely, B is probably the easiest one by inspection to figure out what we're going to do. All right, so let me pause here for a moment and see if you come to the conclusion I'm going to state. All right, so of our four methods up there, which one applies best to this? And hopefully you're leaning towards the square root property, because it's in the form something squared equals a number, right? X minus 3 squared equals a number, begging, right, for the square root property. All right, so we do that by taking the square root of both sides. As we have seen, that introduces a plus minus. Over here, the radical in the square clears out, leaving us with x minus 3. And we have the square root of 16, negative 16, is 4i. If we add 3 to both sides, we get x is 3 plus or minus 4i as our solutions. So we have two solutions here. 3 plus 4i is one of them, and 3 minus 4i is the other. So two complex solutions. Like I said, we're kind of doing a little bit of 1.4 as well, and I think it's not that hard to sneak in there. All right, so there's that one. So we've already used the square root property, so let's knock that one off our list. Now the other three are a little bit tougher, all right? And so let's kind of take a look at these things, right? And so 3x squared plus 5x plus 1, definitely a quadratic, right? And my a in this case is 3, my b is 5, and my c is 1. So completing the square is going to be awfully hard on this one, because I would first have to divide by 3, which now this is going to mean this could be 5/3 and 1/3. We already have fractions, and this process is hard enough. And then to push fractions along with that process, it's like, whoa. So why do we not complete the square? So that leaves us with factoring and quadratics. So let's factor. Well, if we're factoring, UACers have an advantage here, because a times c is 3. So we're going to look for two numbers that I can multiply and get 3, but I have to add and get 5. And the only possibilities are 3 and 1, and of course there's no way they're going to add up to 5. So this basically says that factoring isn't going to work here, because that's not a factorable property. So by a process of elimination, probably the best way to solve letter A is to use the quadratic formula. So again, the quadratic formula, let me rewrite it down here, is negative b plus or minus b squared minus 4ac all over 2a. All right, and so now it's just a process of plugging in the coefficients that we have. And so we've got negative 5 plus or minus 5 squared minus a 4 times my a times my c all over 2 times a. And so now it's just a process of cleaning that up. So my x is negative 5 plus or minus, I believe we get 25 minus 12 in there, all over 6. And so we get negative 5 plus or minus the square root. I think that's going to be 13 all over 6. And you can kind of see, again, square root of 13 is a real number, but it's definitely irrational. It's not nice. So that's probably why the factorization wasn't a very good thing there. So we have two solutions here, right? Negative 5 plus the square root of 13 over 6, and negative 5 minus the square root of 13 over 6. So there we go. So we can now scratch off the quadratic formula. We've used that. So now we're down to factoring and completing the square. So let's take a look at letter C. Well, letter C, again, if it factors, I would definitely would like to do that. But we're again, A is 1, B is 6, and C is 2. And so if we look at our AC, right, 1 times 2 is 2. So two numbers that multiply up to 2, but at the same time add up to 6. And our only possibilities are 2 and 1, and there's no way that's going to add up to 6. So that basically tells us that factoring is out the window. So we're left with completing the square. All right, and the good news is this is a pretty good candidate for completing the square in the first place, because the lead coefficient is already 1, and the coefficient in front of that x is a nice even number. So this is a great candidate for it. So subtract 2 from both sides. We get x squared plus 6x equals negative 2. We've got to take that 6 and divide it by 2, and then take that 3 and square it. So what I need to add to both sides, I need to add 9 to complete the square, and I need to add 9 to that side to balance my equation off. This now factors, so we're going to take advantage of that 3. It factors as x plus 3 squared, and negative 2 plus 9 gives us a 7. So just as by design, completing the square sets up the square root property. So take the square root of both sides, introduce my plus minus, we end up with x plus 3 equals plus or minus square root of 7. Again, you can probably see why this didn't factor very well, because we have a, kind of a pretty hairy little irrational number. Subtracting 3, we end up with x equals negative 3 plus or minus the square root of 7. So we end up having two solutions, right? Negative 3 plus the square root of 7, negative 3 minus the square root of 7. So there's our two real values, right? They are real. They're not nice. They're irrational numbers that basically solve that equation there. And so what's left now is factoring. And when you look at letter D, we probably think, well, isn't it already ready? It's already factored, right? But this is where the zero factor property kicks in, right? What I need, let me sneak it in here, is I need a product equal to 0. Because if I have this, the only way that a product can be 0 is if somebody's 0. When I have a product equal to 6, there's too many ways to get 6. There's 2 times 3. There's negative 2 times negative 3, right? There's 1/2 times 12. So there's just too many ways to get 6, but there's only one way to get 0. Somebody has to be 0. So unfortunately, even though this is factored, it's not set equal to 0. So factoring, right, isn't really finished yet. So we actually have to go in reverse. I have to actually FOIL this out. I think I FOILed it right. First, outer, inner, last. Combine like terms. And then I need to set this equal to 0, so we'll subtract 6 from both sides. So this gives us x squared minus x minus 12 equals 0. So this equation and this equation are equivalent, but I'm now set equal to 0, so when I factor this, and I'm going to use good old guess and check, right? First times first is first, last times last is last. The outer is a 3x, the inner is a negative 4x, giving us negative x. So there's that. So the zero factor property now says that one of those two guys is 0. Adding 4, we get x equals to 4 is one solution. Subtracting 3, we get x equals negative 3 as one of our solutions. So there's our two values that make that function work. And since this is easy to check, right, remember the whole idea behind solving is if I substitute this, 4 plus 2 is 8, 4 minus 3 is 4 plus 2 is 6, 4 minus 3 is 1, so 6 times 1 is 6, so that checks out. Negative 3, well, negative 3 plus 2 is negative 1, negative 3 minus 3 is negative 6, and negative 1 times a negative 6 is 6. So that kind of wraps up what we saw, right? We got to find values that when I plug them in, makes it true. And so there's our two values that make it true. Good review of the zero factor property, and we use factoring. So that should wrap up section 1.3. All right, we're going to do a little bit more work, even though I've kind of snuck it in. 1.4 is more quadratic work, but with more details with complex solutions. So I'll see you guys in the next module and in the next videos. Well done, and keep up the good work.